Let's trace the biomechanics of lifting this coffee mug, focusing entirely on the physics of the shoulder complex.
Perfect. The moment you grasp the mug, you increase the mass at the distal end of an open kinematic chain.
That mass increases the downward gravitational force vector, which acts directly on the center of mass of the arm mug system.
This drastically lengthens the resistance moment arm relative to the glenohumeral joint center, which acts as our fulcrum.
Since torque is the product of force and its perpendicular distance, this long movement arm creates a massive clockwise rotational torque.
To keep the coffee steady, the shoulder must establish static equilibrium, meaning the sum of all torques must equal zero.
The anterior deltoid and supraspinatus must counter this by generating an equal and opposite counterclockwise torque.
But the insertion point of the deltoid is incredibly close to the glenohumeral fulcrum, meaning its effort moment arm is tiny.
Because the effort arm is so short compared to the resistance arm, the mechanical advantage of this third-class lever is way below 1.
Right, so to lift even a light coffee mug, the deltoid muscle tension force vector must be exceptionally large.
That massive muscle force vector pull has a major unintended consequence due to its steep angle of pull.
Exactly. Resolving that muscle force vector into horizontal and vertical components shows a massive upward linear translation force.
If left unchecked, that linear force would cause shear stress, driving the humeral head straight up into the acromion process.
This is where the rotator cuff force couple saves the day by altering the net resultant force vector.
The infraspinatus and subscapularis apply downward and inward force vectors, creating a downward translating moment.
These concurrent force systems cancel out the vertical shear, leaving a massive compressive resultant force vector.
That compressive vector points directly into the center of the glenoid fossa, driving stable joint surfaces together.
The pressure on that tiny cartilage surface area is high, calculated as force divided by the contact area.
Thankfully, the friction coefficient of the synovial fluid is incredibly low, minimizing thermal energy loss and wear during the movement.
Now look at the scapula as I set my mug down. The scapulothoracic rhythm changes the system's spatial coordinates.
The instantaneous center of rotation continuously shifts as the scapula rotates upward in a 2-to-1 ratio with the humerus.
That change in the geometric orientation of the glenoid vector preserves the optimal length-tension relationship of the deltoid.
By altering the muscle's line of pull, the physics prevents active insufficiency and keeps the moment arm viable.